Okay, so we define the molar mass as the mass in grams of 1 mole of a compound or a molecule. So this mass is going to be, this molar mass will be important for converting between grams that we measure in the laboratory and moles that we understand theoretically as Avogadro's number of units. So for example, we know that water has the formula H2O. That is, in 1 molecule of water, we have 2 hydrogen atoms and 1 oxygen atom. So in 1 mole of water, we will have 1 mole of oxygen atoms and 2 moles of hydrogen atoms. We know that from the atomic masses that are in our periodic table, that 1 mole of hydrogen weighs 1.008 grams, and 1 mole of oxygen weighs 16.00 grams. And so to determine the mass of 1 mole of water, we are simply going to add up those component atomic masses. That is, if 1 mole of hydrogen weighs 1 AMU, then 2 moles of hydrogen weighs approximately 2 atomic mass units, or 2 grams per mole. So in the case of water, we simply add 2 times 1.008 grams per mole plus 16 grams per mole to tell us that the molar mass of water is 18.02 grams. Okay, that is 1 mole. If we measure out 18.02 grams, we will have Avogadro's number of water molecules. And this is going to hold true for any compound that we were talking about. If we have the formula of that compound and we have a periodic table, we can very easily calculate the molar mass, the mass of a single mole. Okay, so let's take sulfur dioxide as an example. In 1 molecule of sulfur dioxide, we have 1 sulfur atom and 2 oxygen atoms. So in 1 mole of sulfur dioxide, we have 1 mole of sulfur atoms, that is Avogadro's number, and 2 moles of oxygen atoms. Well, we know that 1 mole of sulfur atoms based on from our periodic table weighs 32.06 grams, and 1 mole of oxygen weighs 16.00 grams. So 2 moles, did it again, 2 moles weighs 32 grams. So to determine the molar mass of sulfur dioxide, we're simply going to add 32.06 plus 32.00. We don't really even need a calculator for this, so 1 mole of sulfur dioxide weighs 64.06 grams. That is, the molar mass of SO2 is 64.006 grams per mole. Okay, so it's as simple as adding up the component atomic masses. Now, while we're doing this for the purposes of this class, I would like to adopt the convention that all of our molar masses will use 4 significant figures, that is 4 digits total. Okay, let's do two more examples here. And we're going to look at some polyatomic ion-containing compounds. So here we have ferric hydroxide, or iron 3 hydroxide. In 1 mole of ferric hydroxide, there is 1 mole of iron, and iron has a molar mass of 55.85 grams per mole. We again find that on our periodic table. Then we have oxygen. We have a total of 3 hydroxide groups, so that's a total of 3 oxygens and 3 hydrogens. So each mole of oxygen, has a mass of 16 grams per mole. And hydrogen is, of course, 1.008 grams per mole. Again, I'm using 4 sig figs for all of these values. So now when I calculate the molar mass, I'm going to take 1 mole of iron, 2 moles of oxygen, which would be 32, and I'm sorry, I'm going to take 3 moles of oxygen and 3 moles of hydrogen in my calculation. Okay, and I should end up, if I plug these into my calculator correctly, I should end up with a molar mass for ferric hydroxide of 106.9. Again, that's simply adding up these component atomic masses. So we're going to take oxygen times 3, hydrogen times 2, and then add that to iron. I want to do one more quick example. I'm going to skip sucrose here. Many ionic compounds come in the form of what we call hydrates. That is, they have water as an integral part of their crystalline structure. So one common example of this is cupric sulfate pentahydrate. So for every 1 mole of this compound, there are actually 5 moles of water molecules bound within the crystalline structure, and that's typically indicated using this sort of a designation, where there will just be a little dot there and then the number 5, H2O, saying that for every 1 mole of copper, there are 5 moles of water. So when we calculate the molar mass of this compound, that is the mass of 1 mole of cupric sulfate pentahydrate, we need to take into account those 5 moles of water. So we're going to start off with listing our atomic masses. So copper, we look on our periodic table, 63.55 grams per mole. We have sulfur is 32.06. I'm just going to leave the units. Oxygen, we have that's 16.00, and we have 4 of those. We're going to multiply that guy by 4. That'll give us 64. Okay, and then for water, we're going to again add up the components. We've already done that, so that's going to be 18.0. We're going to round it off to 0.2. Okay, and so we're going to multiply this by 5. Okay, so we're going to take that 18.02 grams for 1 mole of water, and we're going to multiply that by 5. So 18.02 times 5 is, this is going to be 90.1. Okay, and we're going to add to that 1 copper, so plus 63.55. We're going to add 1 sulfur, plus 32.06, and we're going to add our 4 oxygens. 4 times 16 is 64, so plus 64, and we get the molar mass for cupric sulfate pentahydrate as 249.7 grams per mole. So 1 mole of cupric sulfate pentahydrate weighs 249.7 grams.